This will be for the con assignment, subsets of sample spaces. So it says a teacher randomly chooses a two-person team from a group of 4 students. The first person chosen will be the presenter, and the second person will be the researcher. 2 of the students, Amir and Aaron, are boys. The other 2 students, Caitlin and Denise, are girls. All the possible outcomes of the team selection are listed below. Okay, if we take outcomes 2, 3, 5, 6, 7, 8, 10, 11 as a subset of the sample space, which of the statements below describe this subset? So let's look at these below here. Okay, they highlighted all the possible outcomes. All right. So the multiple choices describe boys and girls. All right, let me see here. First person is the presenter, second person is the researcher. Okay, sometimes for these you might have to take notes. So the first, let me see here. The first is a presenter. And the second is the researcher. All right. Amir and Aaron are boys. I'll write it over here. And Caitlin and Denise are girls. All right, so for some of these, you might have to take notes on the write-up. All right, so let's see. All right, so it's the ones highlighted in red. All right, so for Amir and Caitlin, it's boy-girl. And for Amir and Denise, it's boy-girl. Aaron, Caitlin, Aaron, Denise, it's boy-girl. Caitlin, Amir is girl-boy. Here's girl-boy for number 11 and girl-boy for number 12. I'm sorry, 10 and 11. So let's see. All right. So subset of all teams made up of either all boys or all girls, definitely not. All teams of 1 boy and 1 girl, that sounds correct. It says choose all answers that apply. Subset of all teams were having a girl as the presenter. No, because the girl would have to be first if that was the case. And sometimes the boy was first because the first person is a presenter. Subset consists of all the teams not made up of all boys and not made up of all girls. I would say that's true as well. So B and D. All right, Harry Potter is at Ollivander's wand shop. The one must choose a wizard. Harry cannot make the choice himself. The wood types available: holly, elm, maple, and whinge. Core materials are phoenix feather, unicorn hair, dragon scale, raven feather, and thestral tail. Sample space outcomes listed below. What is more likely? Okay, this is easy. All right, here's all the outcomes, but look at the choice. Harry will be chosen by a wand that does not have phoenix feather. Harry will be chosen by a wand made of either holly or elm. Okay? So they want to know which event is more likely. All right? Harry will be chosen by a wand that does not have a phoenix feather core. Here is the column for phoenix feather. Okay? So it says does not have phoenix feather core. So that would be all of these right here. How many options? 1, 2, 3, 4 times 1, 2, 3, 4. 4 times 4, 16 options for that. All right. And now, part B, or answer B. Harry will be chosen by a wand made of either holly or elm. All right. Here's the row for holly. Here's the row for elm. Okay, so if I circle these or put a square around, rectangle around it, how many options are there? 1, 2, 3, 4, 5 times 1, 2. 5 times 2 is 10. So which one is more likely? Well, I would say this one. Okay, there's 16 possibilities for part A, and for part B, there's only 10. All right, it doesn't matter how many. They're both going to be divided by the same total if you wanted to calculate the probability. So it's going to be answer A. All right, you and your friend are playing a game where you flip a coin and roll a fair 4-sided die. You win if the coin is heads and the die lands on an odd number. Your friend wins if it's tails and the die lands on an even. Tie if it's heads and even, or tails and odd. All right, let's take notes on that. You win if the coins is head and the die is odd. Okay? You win if the coin is heads and the die is odd. Okay? Your friend wins if the coin is tails. Let me just write, you get the win there. Your friend gets to win if it's tails and even. Okay? So the friend wins if it's tails plus even. Okay? And a tie, heads plus even, tails plus odd. Heads plus even or tails plus odd is going to be a tie. Okay, so those are your options. Choose all answers that apply if we take outcomes 2, 4, 5, and 7. Okay, those are all highlighted in red, 2, 4, 5, 7. So let's see, for 2, heads plus even. Heads plus even is a tie. Outcome 4, heads plus even. That's a tie. Outcome 5, tails plus odd. That's a tie. And 7, tails plus odd. That's a tie. So I think those are all the outcomes where you tie. All right. So let's work our way up. All the outcomes where you win or lose? No. All the outcomes where you win? No. All the outcomes where your friend wins? No. All the outcomes where you tie? Yes. So that's it. All right, Joe and Maxine are playing a game. They flip a fair coin 4 times, try to predict the outcomes. Maxine thinks the probability of getting all heads is equal to the probability of getting no heads. Joe disagrees. He thinks the probability of getting all heads is greater. All right, let's see. Let's take notes on this right up here. So, Maxine thinks all heads is equal to getting no heads. All right, so for Maxine, she thinks all heads, I'll just put an H. All heads equals no heads for probability. And the other one is Joe. He thinks all heads is greater. All heads probability is greater than no heads. All right. Maxine says all heads equals no heads. So let's see. All right, we're talking probability here. So for all heads, how many options do we have for all heads? Just one, right? Okay. And we see the total is 16. The total number of options is 16, but it doesn't matter. For the probability of all heads, it's just going to be 1 divided by the total, right? And how many options do we have for no heads? Well, that would have to be all tails, okay? So again, there's just one option. 1 divided by the total, okay? Obviously, the total is 16. You don't even need to know that for this. So we can see already Maxine is correct. 1 divided by the total for both all heads and no heads, all right? Just to prove it, Joe says the probability for all heads is greater. Well, we said all heads, there's only one option out of the total. And for no heads, how many options are there? Again, we already said 1 out of the total. Okay, so this one can't be greater. That can't be true. They have to be equal. So Maxine is correct. That is answer A. All right, it just says choose one answer. Some of them say choose all that apply.